Hey guys, how's it going? Welcome to another episode of Ferris Makes Hardware. Um, I took last week off. I actually don't remember why. But I haven't made much progress on most things in the last 2 weeks. Um, After the last streams, I started thinking a bit more about the design of the vector unit that I was working on, which I do not have the diagram up of. This is something else because I want to maybe start describing the CPU in a little more detail in order to start pipelining stuff. I didn't get very far with that, but I'm working towards that. Anyway, I was thinking about that vector unit and thinking that there's some design decisions I don't know if I'm happy with there. Like, of course, it's nice to have a thing that accelerates dot products, but I might want to have it do more or do things in a different way, and maybe not floating point. And some of that thought stuff was sparked by someone on YouTube who was discussing that stuff with me in the comments. So we went back and forth a bit. And then I just kind of like took a break from it and decided, okay, I'm going to get away from it and then come back and start working on it once I've thought a bit more about it. And in the meantime, I kind of want to get caught up on some other stuff. So I mentioned a few weeks ago that I had been working on this read cache stuff. Oh, and also I think I actually did this weekend do some random stuff. In fact, I think I went through in kaze and actually wrote out a bunch of stuff. Okay, maybe I wasn't as unproductive as I felt like this week. I wrote a bunch of tasks and just kind of got some stuff I was thinking out into tasks. For example, what I want to do today, which we'll get to, is come up with some kind of solution where I can generate code for the generated sim modules that will dump some tracing information, optionally, of course, because we need to make sure that things are really fast when you don't want that. But at the same time, especially for some of these tests, I want this to be more or less automatic. So I don't know how this is going to look yet. I want to kind of start hacking some stuff together to get a better idea of what that might be, and a lot of other things. So things about like document how we detect errors and handle them in the language, and other stuff. And in addition to that, I also went and I actually fixed a bug. Maybe not a bug. Actually, I would consider it a bug. So earlier, I had done this thing where the generated sim code would rely on implementing or deriving the default trait in Rust, which would default initialize most of the fields on the struct. So we didn't have to generate a lot of code to basically zero initialize the state of the generated hardware units. However, that actually was not correct. Like, I kind of did that as a shortcut when I was like bootstrapping the compiler, and I just left it. I still use new in the user code for the most part, but then that would just call default internally and then set up the memory stuff. And actually, since the memory stuff was implemented, and what that does is it creates a vector for the memory contents for every memory instance that you have in a module. This new and default didn't line up anymore. So it was actually a user error if you called default, because that wouldn't initialize the memory stuff. So by the time you actually tried to simulate stuff, it would crash. And again, you're always meant to use new. So it wasn't really an issue, but I actually did run into an issue where I wrote a test and then it crashed, and that was actually why. So I made sure to actually fix that properly. So now the compiler dumps out a bunch more stuff for default states in new. And of course, that got me thinking as well, like I still need to come up with a way to randomly initialize these structs. And the thing is, the reason why this stuff is not like trivial is because currently when you generate the Rust sim code, the code that you get has zero dependencies. It's just straight Rust code. I think zero dependencies is actually maybe not correct. So let me try to pull up an example here. So if we look at, let's see, I guess what I can do is build this read cache project again, because I think this is a good example for a lot of reasons, actually. Let's see. By the way, hi guys in the chat. Daniel Collin, G Superlin. Good to see you guys. Yeah. So a quick refresher, this read cache thing is this little, like, I want to start putting caches into the design, and I started just by designing a read-only cache and testing that in isolation. And then I want to kind of build on that design for the instruction cache in the CPU, for the texture cache in the GPU, and maybe a couple other kinds of caches that I might want. And they support, well, right now it doesn't yet, but it supports things like invalidation and maybe multiple, or maybe an adjustable like cache line size. Right now it just matches the size of the bus width going out of the cache. So I don't know. There's a few features I want to add to that. And one of the things is that when writing this, it was kind of difficult to debug. And especially since I don't have any way of like generating traces, I hacked it together for this particular test. So in addition to doing the sim stuff, I added a bunch of this trace stuff. And I had done this before on the stream. So I've done this a couple times now and kind of have a good idea of what like we need to do to get useful trace information. But I obviously think that this is the compiler's job. You should be able to tell the compiler that you want to generate a module that can also give trace output, and it should be able to do that. But anyway, so I just ran this test, and if we go into the target directory, it's going to be in one of these. Just digging here. This is the generated Rust code. Yeah, Colin says, make sure to do heavy testing of the cache. I had some issues in cache software I did once, which didn't invalidate some lines correctly. Yeah, exactly. Yeah, that's exactly the intuition here, is that it's already a pain, and I've already made some mistakes that I had to debug by looking at traces. I definitely need to do more than adding trace support, right? Like I need to definitely do some fuzzing tests, and I might even make like a proper formal spec for it as well, even for a really simple cache, just to make sure I get some of these designs right. Like even outside of the RTL. So yeah, I totally agree. It definitely needs to be tested a lot, and I want to make that process easier. So as another example for some of these other things that I've done, like this peak buffer and even the FIFO, I've built these fuzzing tests where you can give it a random seed and it will randomly do writes and reads and make sure that all the data goes through there. And you can test it with like, a million elements if you want with different seeds. So anything like that to just get a lot of confidence on this stuff is really good. Definitely need that work. But yeah, I want to make that process more automated. That's really the point I'm getting to. Which again, it should be the compiler's job, or at least it should be a compiler feature to be able to do this. Now, you obviously don't want to always give the code the ability to trace, because you don't want to have any overhead in some scenarios when you're just running stuff to test things. Because you kind of have different ways that you can test things. Like with this system, it's kind of nice to be able to just run the whole system and just test like a GPU feature by going through the whole CPU and everything. It won't be particularly fast, but we should still be able to make that as fast as it can be without necessarily dumping trace information, which slows things down a lot, because even with not that many signals, if you run long enough to do anything useful, you've run a lot of clocks, and that means you're still generating a lot of data. And even just looking at like disk bandwidth, it's really, really slow. So that becomes your bottleneck, and it's really bad. So yeah, I want to make this better. So looking at some of the generated code now, I'm going to bump up my font size again because I forgot. Let's do something like that. I mean, it's pretty straightforward. Whoops, some books I was reading. Yeah, so it generates this read cache struct, and then it has the inputs and outputs just as members on the struct, and then as internal members, you have the state of all the registers and their next states. So as signals propagate, these are like the inputs to the register, and these are the current outputs. And then all of the memory stuff, which includes some logic for the read and write ports, which also behave like registers, and then the data array itself. So I mean, basically what you'd expect. And then what I changed this weekend is that now new also adds all these like default initializers for all these things. But again, the kind of important thing here is that there's no, if you want to run this, you just instantiate this object. You call new, and then you call reset, and then you call pause edge clock and prop. Like you just tell it to work, and it just works, right? Like that's the whole thing. And that goes for any module. And the only real dependencies that this has is, I think, on vec, because yeah, this is what it does to create the actual memory contents. Vec, and then does into box slice. And like that's it. And of course, it also depends on some other things, because like, again, it does logic. So if you have like a U128 in here and you add those, then obviously there needs to be support for that. But I think actually the compiler takes care of that. I don't think it ever calls out to stuff. Yeah, box as well, I guess, because of this. Yeah, definitely. So heap allocation, and then in particular vec, which I think is reasonable, because you just it feels like no dependencies, but it is some dependencies on the standard library, and I think that that's okay. Maybe someday I would add like a no std option, but I don't really think I need that right now. But anyway, I want to keep it that way, right? Like just to show how this bootstrapping works, if we go to this read cache project, it's just a regular Rust project, and you have kaze as a build dependency, as well as this RTL project, just because it uses some helper stuff, I think. But this is really all you need. And then the build script, well, right now it has all the RTL in it, but normally this would be elsewhere. But then the build script here creates a file to dump the RTL to, which is this modules.rs in this out directory, and then generates the module and calls simgenerate. So it generates, the simulator for the module into that file. And then here I have a main.rs where I ran that stuff, and then I also have this tests. And tests is, like, ideally I would just run most of the tests as actual Rust tests, where, again, you instantiate the module, and here we call, like reset or whatever, and then do whatever we need to do, and just do regular asserts to kind of test the thing. And so this would test like specifically like targeted things. So in this case, this is a long test, but it actually takes a lot to test this. So what it does is it issues a read to address 0, and then it makes sure that the cache actually asks then the memory to get that. It returns some read data, and then makes sure that propagates all the way back up. And then it's, I think it issues another read on the following cycle. I don't remember exactly what it does. It tricks that it can, then it does issue another read, and then it expects that doesn't go out on the other bus, and that the proper data is still returned. And then also that it stops reading after that. So it's a lot of these little things, but at the same time, that's kind of still a nice thing to kind of test one specific thing. So this in this case is read the first address and make sure that actually gets cached. You can read all, which I actually don't know if this works right now, and then read all with some delays inserted in there. So just those kind of like targeted tests. And then in addition to that, I have a main.rs where I want to do the fuzzing test, which I haven't done yet. I've only hacked this trace stuff. So it's a bit of a mess, but I think this is kind of the right approach. The only difference is that I want to move the tracing stuff out. But then again, I would still like this generated modules to look more or less the same. But I think I want to add to the generator, I want to add an option that says also generate trace data. And then what I want to do is I'm not entirely sure how the bootstrapping might look, but I want to have this module except maybe whenever I do pause edge clock, for example, or maybe prop, I'm not entirely sure. Probably the clock one. I wanted this to accept some kind of trace. So I'm thinking something like this. We'd have T trace. I know this isn't valid Rust, but bear with me here. Something like this. And then in addition to actually propagating the state through all the registers and everything, it would also dump trace data to this. And then this trace thing is suddenly a dependency again, right? Because then this has to be defined somewhere. And then, so I think I'll introduce like another Rust crate, which is like kaze trace or something. Like I have no idea what it's going to be called yet. But then that would contain this module, and you'd have this. But again, this kind of code would only be generated if you ask for tracing. And it may even make sense to make this optional. I'm really not sure how that's going to look yet. And that's what I need to kind of figure out just by doing, I think. But again, it should be entirely possible for the compiler to do this, and it should be appropriate for the compiler to do this. So that's kind of the main part. And I think I'll just dump, like, for example, all the registers and maybe some of the memory contents. I'm not entirely sure what I need for that yet. And the other reason I want to have a trace thing like that is because I want to be able to swap this out. So, for example, I want to provide a library that contains these trace objects that would support different formats, for example. And I want to make this general so that a user could make their own thing, and this would essentially push different trace data into whatever a user would define. So if you want to make your own format for tracing or whatever, you should be able to do that via the same mechanism that the library would. Although typically what you want is VCD, which is value change dump. That's what everyone uses. And then maybe you want things like wave-drom, which I think is really nice. Yeah, it is really nice that these tests run in parallel, which I think will really help. So that actually leads me to the next thing. So this is what I want the code generator to do, is something like this. Again, the details need to be fleshed out more, and I don't really know a better way to flesh out those details other than to start coding. That's the most fun way to approach it, at least. So that's one thing. And then additionally, we need to know how to handle the tests, because I think when the traces are most useful is when a test fails. So for example, if you run one of these fuzzing tests, or if you run one of these unit tests and one of these asserts fails, then what I want to see is I want to see all of the signals that are possible to be traced in a file that I can pull up in a waveform viewer and say, like I want this to fail, and then I also want, maybe it's better to describe this in code. Something like, I don't know, equals trace new, and then you would give this read first adder, whatever. So something like VCD trace new, and then maybe it's even like concat, I don't know, some test dir, whatever. Something like this. And then whenever you do positive clock, or maybe you pass it in when you create the module, that could be a possibility. In fact, that probably makes some sense. I really don't know. But then the idea here would be that whenever then this is always dumping out trace whenever like positive clock is called. And then at some point, if one of these fails, then that of course unwinds the stack. And then this file IO gets flushed and everything. And then I also want this, as it's flushing, to say, data printed to whatever. So when this test fails, I should see that output that the data was printed to like a specific file. And then I open up my waveform viewer and I look at that file, and I should be able to see everything that happened. So as long as this is some kind of like tempter, and then, yeah, something like this. And maybe I have some kind of convenience thing for this. I'm not entirely sure. But I think this kind of approach would make a lot of sense, because then I would just add this to all my tests, or at least all my new tests. And then if I start having test failures in older code, then I'll just add these couple lines and make sure that this is generated with trace info. That wouldn't be very difficult. And everything would just kind of work, I think. So that's what I'm thinking. And I'm thinking I do actually like the idea of passing in trace to the constructor, because then all the other code looks exactly the same. So if you conditionally enable or disable tracing, then only this code actually changes, which I think is kind of nice. Because again, I think some of these tests I don't want tracing enabled just because of the CPU overhead. So I have some of these like top level ones where I have like this XW Blaster, this struggle thing, where then I don't want traces. It's just going to be too much data. But for these targeted tests, I definitely want them. So that's going to be conditional. And that's also another part that plays into this, is in Kaze itself, in the test suite, I have this sim tests directory. And what I actually think I want to do is take all of the tests that I already have and actually generate 2 versions of them so that I can test that both versions of the compiled code with and without tracing actually still work and behave as expected. So it's kind of a lot to do, actually. And this is why I've been putting it off for so long, just because I foresaw that this was going to be a lot of stuff. But I think it's going to be manageable. And then a small tangent, I think this other task where it's, come up with random initialization solution for the generated sim modules. This also has similar constraints where I want to be able to conditionally add a way where you can say, sum my RNG here. And you would give it some kind of random number generator that would use. But again, it's important that if you don't want this, the code that gets generated wouldn't rely on any of that, right? So you'd want a tracer, and then maybe also conditionally you'd want R, which is some kind of random number generator. Something like that. In fact, I think I just already decided that I wanted this here. And then these would go on the module itself. Something like this. And again, then a user can make their own random number generator, and it wouldn't necessarily depend on a specific crate that's used to implement this. Again, I kind of want to be able to supply some default ones that are nice, but I want to have those as, for example, crate features. So in the default case, you just don't have any of this out of the box. And then if you want to, you would enable those features. And then you get them at the cost of having to include some additional modules as runtime dependencies, which I think just makes sense. So in that case, you just put them here. So in this case, we actually do have a couple random number stuff because I want to have those fuzzing tests here as well. But it's going to be basically the same thing. And then again, that's a reasonable thing to do because then you as a user have asked for it. So I think that makes a lot of sense. So yeah, they're both kind of related, but the one I want to work on is actually tracing. No idea how far I'm going to get with this today, but yeah. So just to refresh my memory on these notes I did. Yeah, performance is really important, which I talked about. Tracing something non-trivial can easily produce a lot of data, so you definitely want to have it be disabled. As is today, the simulators have 0 dependencies beside basic runtime functionality. I want to keep it this way. And we don't necessarily want to also generate a bunch of extra boilerplate to output a certain format. Yeah, that's the other thing is when generating these dumps, there's things like this Rust VCD crate, and you may not want to rely on this third-party thing as a user. So you shouldn't have to. But at the same time, me as an implementer for one of these trace things, like I don't want to care about this part. I want to use this crate to implement that. And I think that's really reasonable. And that also is why I want to expose that functionality to the user. Like they could have their own trace trait implementation that would be the glue that hooks something like this together. So I think that makes a lot of sense. And then, yeah, at least 2 formats I could think of is VCD and this wave drum thing, which I really like. Both because it's a simple format and because it makes nice trace diagrams. And then, yeah, so tracing should be optional. Enabling tracing should not create additional library dependencies unless a user asks for it, which is really good. And this constraint I probably won't worry about for like a sort of prototype implementation. So we'll kind of keep that in mind, but it doesn't necessarily have to be like that in the first iteration. At least one default trace implementation provided, and that's going to be VCD for sure. And it should be easy or automatic to get trace output for a failing Rust unit test that's based on a generated simulator. Great. I think I covered everything. Some loose ends. It might make sense to introduce some kind of compilation profile that can allow the code generation to optionally insert or emit extra signals. Yeah, so this is another feature that I might want to add. So let me give I already have a good example of this again in this read cache. So when debugging this, I needed to see some state that wasn't visible from the inputs and outputs of the module, because when you generate this code, that's all you see is the public members of the struct, which is only the inputs and outputs. And intentionally, you don't have access to these registers and you don't have access to the memory. And this allows the simulation to actually work. Otherwise, it's very easy to violate some functionality or invariance that your logic has captured. But then you violate by messing with some internal state. As with any internal state, right? That's typical. But I needed to get at some of these things. So in particular, you see that I added some outputs for debug state and debug issue buffer occupied. And these, I don't actually want them to be here. And imagine if this module had been buried a few modules deep, I would actually have to add, like, if I wanted to get from this top level, I would actually have to add plumbing to plumb that value out. So I would have to add outputs in all these modules and code to actually hook them up to the top level output stuff. In this case, the module was the top level module, so it wasn't that bad. But there are definitely cases where this might be buried deep inside something else. So I want to be able to get those out without having to do all that extra plumbing. So yeah, in this case, I just explicitly made these output ones. And I don't want to do that. What I would rather do is something like m.debug or trace or something. And then you might say, I don't know, even just the name of the thing, actually. And then you would give it this whatever signal it would be. And then I like this idea a lot because then most of the time this wouldn't need to be there. But then if you actually generate tracing, then we can generate this kind of all the way down and fix all that. And again, a compiler is suited to do that rather than a user. So I think that's also kind of cool that actually all the things I'm describing, like, you can do by hand if you want to right now, which that's another like testament to keeping things dependency free and for the most part open, because I have been able to work around not having these features, and that's great. That's why you want to make composable things rather than things that contain a ton of features. However, I think that these particular cases, specifically random initialization and tracing, are so important in debugging complex logic that I think that they need to be supported in the compiler. So definitely convenient stuff, but I think that that's a good place to kind of draw the line. So yeah, so that's what that is. I don't need to tackle that today, but that's something to keep in mind. And then yeah, there's actually that note there. All of this can be done today manually, either by inspecting the module via some additional debug outputs, which is what I did here, or by using a traditional RTL sim compiler. Yeah, that's the other thing you can actually do is you can have Kaze just generate Verilog and run that through Verilator or something. And that's what I used to do. If you guys remember before I did Kaze, that's how I used to simulate everything. But as it says here, I don't think that's a satisfactory solution because it requires an unreasonable amount of extra effort to bootstrap. And there ends up being a lot of duplication of information about which signals are available and which are known by the compiler. So yeah, I think I summed this up in a lot of detail. I don't think there's much else that is related to this that I wrote down. Except, yeah, I made a ticket to document some use cases, which obviously this ties into that a bit too, because I want to document how to actually do this stuff. But yeah, I think this all makes sense. And again, Kaze is just one of these things that I'm specifically making for my own hardware projects, especially the Xenowing, but I'm also a bit forward thinking about it. Like, I know that I would like to do FPGA stuff for a long time coming, and I think that some of the restrictions that Kaze has might seem really limiting. For example, only having one clock domain, having an implicit reset. But I think as well that that's actually, if you partition your design right, that's actually not unreasonable at all. So I think it makes a lot of sense. And I can just imagine designing like sound chips and stuff for fun, or even like one of the pet projects I kind of want to make is a really tiny artificial intelligence accelerator, which is kind of funny because I work at a company that does that. Obviously not a small one. So I have to be careful about like what I could put into it, but I could make like kind of a minimum viable thing, or like even just anything where I just plop down a bunch of really simple cores and make them talk to each other, like kind of sounds like a fun thing to work on. And I feel like this language is still what I want to use to do that. So that's why I'm kind of, 4-bit multiplies totally. something really like crazy limited in terms of arithmetic. I love that a lot of those ideas are coming out. Some of them I don't think are that great, but who cares? People are trying them and it's fun. So I enjoy that. And also I worked a bit on that floating point stuff before the last stream. And I didn't get that far, but I was working on like multiplies and adds for like specific use cases. And I intentionally made, actually, I think I have it here. Where did I put that actually? I don't remember. Oh yeah, Softy. That's what it was. And I intentionally made it so that you can make formats, floating point formats, where you specify the number of exponent and the number of significant bits. So it behaves almost like IEEE with a lot of the extra fluff, which I call it fluff, but it's actually typically very important. But for something like this, like if I made an ML accelerator or a dot product accelerator, I probably don't care about most of those special cases. And then it's actually not that hard to implement. And with these being parameterizable, I can play with some crazy formats. So I think that's also why I kind of did that, is because, again, thinking a little bit ahead, I think that this is kind of a useful thing to play with. Now, this is only software, but that's where you play with stuff and kind of model things first and get a feel for it, and then you can implement it in RTL. So yeah, I see this being a project that I will use for at least a couple years, just for random projects. I think that'll be fun. 0x bits, 32 sig bits. I wonder if I actually support that, because I added some checks. No, you actually needed a min x bits here. I don't know why I did that, actually. Probably had a reason. Who knows? Yeah, boo, exactly. Yeah, it's funny. I really like when you mentioned the PS2 stuff, Daniel Collin, because I'm still not as familiar with it as I probably should be. Like, you always tell me to read the manual, which I think is great. I need to do that. But also, yeah, there's a lot of accelerators that do that. They say based on IEEE 754, and I think that's really reasonable. For in a lot of cases, of course. Yeah, keep doing that. Keep nagging me about it. No worries. Yeah. All right. So I don't really know where to start with this other than just talking about it like I have done now. So I might as well just start somewhere. And in fact, I think what I'm going to do is... Yeah, exactly, man. IEEE 754 fanfic. Let's see. I think what I want to do is just say, like, screw the conditional stuff at first, because that just makes it a lot easier. And just say, what if I just generated this module here and it did contain all that trace stuff, and I only cared about that. And then I wouldn't even use a separate crate to define that trace struct. I would just do that in the build script for this module, and then try to hook that up. So basically replace all of the stuff that's in main here. Slowly move that into something generated. I think that's where I start, because again, I don't like the thing that I'm missing here is, like, clearly I have some kind of vision for what I want this to do, but it's the details I'm missing. So yeah, I guess I'll just start. And the other thing too is when I wrote this trace, I added like these signal trace structs, which are kind of nice because they keep track of like the old value and see if they change. But to be honest, I think that these are all implementation details already of yeah, like the generated trace thing. In fact, actually, yeah, we'll just have to see, because ideally you make this like fully generic, and then if we look at how that might have to look, so let's see if we go to, yeah, if we just did something here, like, yeah, this has struct trace, but yeah, struct new trace, whatever. Like, what is this? In fact, we can even do this. What does this trait actually look like? So in the simplest case, you might think it's something like, add value, something like clock, just to keep the name the same. And then this, I'm not sure, because you want some kind of like signal identifier, and then the value. And the value depends on the type of the signal. And like you definitely don't want this to be like a string, right? Because that's just going to be stupid slow. And then of course the value can change as well. So I might even do like add value with different types. Maybe something like this works. I don't know if that works to do a trait like that, so it might even just be add bool and then the different types that you would do. Could also be something like this, where you have a dynamic type here, but I think that's actually not what I want. I think I want like different types here. The types here never change. Like the type of signal never changes at runtime. Maybe it makes sense to do something like this. I kind of like this as an idea, because then you can have this return a signal ID that can be whatever type you want as an implementer of this. I think taking a string here makes sense, because then when you create the module, it will just call this a bunch of times to add the signals, and then as you call these, like positive clock, for example, this will yeah, add a bunch of values and then call tick or something. I'm not really sure. Again, I'm not sure what we need here yet, but I think something like this kind of makes sense. Because, for example, I don't like the idea of, well, it might be the same anyway. Like, if this is dynamic and you have something like enum value, and then here you might have like bool, something like that. Then whenever you do add value, you kind of have to check or unwrap it the right way based on what you know the type of the signal is because of this. So be something like this. And so then you kind of have to have these checks that the type of this coming in here is based on this. Maybe that's not too bad. I guess I could start with that. It's probably efficient enough. Maybe not. And then handling errors via this is like this wouldn't allow you to have mismatches like that. I mean, you wouldn't expect them. You expect the compiler will generate these to be correct and line up and everything, but yeah. Yeah, probably best I just get started on something. And how do you do this in Rust again? You have these associated types, I think. Let me look that up. something like this, I think is kind of cool. Yeah, that is what I mean, Daniel Colin. That's what I would do for implementing my own. So actually, this would be trace, right? And then if I do, like, I think this is what I want the compiler to generate code where it expects a trace to look like this. And then when I make my own, so like struct my trace, whatever, and then impl trace for my trace, and then you do signal ID equals U32, for example, I think. Right? Is that how you do that? I think so. Yeah, it looks like it. And then you would implement these functions like this. So I kind of like that this is handled this way. And then again, the module is going to be something like this. However you define that again. So what comes out of the compiler is going to look like this. And so then when you add tracing, it'll do something like this, or it'll say like, I know, my signal ID or T signal ID or whatever. I think that's how you do that. I don't know if this syntax is correct, but I'll figure it out. I mean, worst case, we just end up also having to do something like this. Type signal ID is something. I'm not sure. I think it's possible to do this. I mean, otherwise, you just have something like this. Or like this, and then, yeah, I'm not sure. We'll have to figure that out. But I like that then this isn't, like, we don't constrain what this ID is. If an implementation wants to be stupid and use a string, then just why not? So I think that makes sense. Yeah, so here when I call like positive clock there, this is gonna call this one on the, or it's gonna call add value bunch on the trace thing, and then it's gonna call clock here to sort of tick that out, and then this is gonna actually dump the signals to whatever serialization it's gonna do. And I think this is the right interface because a lot of formats will, like, they won't actually output anything unless the signal is changed. And I think this is where that logic needs to live, because that's dependent on the format. There might be a format that exists. I mean, I don't know of any, but there might be one that a user might make up where they do output all the values at every time step. So we want to be able to, a user should be able to do that. Like that kind of optimization, I believe, is not the job of the compiler. That's the job of the trace implementation that knows about a format that might take advantage of that kind of optimization. That's what I think. And that's another reason why I want to make this. I want to have it generate code that's generic here rather than making this dynamic. Because that should be a lot faster. I don't want to have dynamic dispatch for these methods. Especially not when the language allows us not to. I think that's nice. The downside of that is that you can't make a module and then suddenly like use it for two kinds of tracing or make that dynamic. But you can work around that because you can make a trace implementation that calls two other trace implementations, like under the hood. So that's still possible. And then it's up to you to make that fast and everything. So I think this is all right, actually. And then eventually to do move to some kind of helper crate in kaze. But for now, they're just going to live here. I actually don't know if they can when I think about it because of this stuff. Or because these two types. Like if this is going to be based on this, then all of these need to be available. Well, actually they don't, because what I can do is change the build script to just expect some other module. Because the way that this ends up being bootstrapped is actually really basic. In main, I thought it would be in here. But I guess it's here that's done. This is what happens, is it just includes the text from that generated code here. So I guess I could make a module that's like test helpers or whatever, stuff that in there. Probably have to do that. But I'll do that in a second. I got to generate the code first, I think. Change the compiler. So that's another thing. Let's see. We have to change some dependencies so that we depend on a local build of kaze here. So we need to do that here. I think it's this. And then we need this as well for this RTL project, which is in here. And I think this is that. And I'm not entirely sure how we're going to get a temp directory to figure out where to put these generated trace files either. I don't know yet. But that's the kind of thing that I think will be easy to figure out once we have to make a decision. I wanted to put off doing this work for longer, but I just don't think that I can reasonably work on all this cache stuff without having this be easier. So I think it's good to do now. Yes, trace is defined multiple times because the way I did this. Because trace here is like this. Oh, nice. That's perfect, Daniel Cullen. I love it. That is perfect. I'm just being lazy here. Oh no. I have to be slightly less lazy. Make it match case. And actually, I guess I could do this. Is this match whole word even? Then I think, yeah, that's even better. Just to avoid this issue. Yeah, magic. I'm using magic to... Yes, G Superland asks, sorry if you said this already. What are you using to visualize the traces? So good question. I plan to add VCD dump. Although currently what I've used to test is I've used Wavedrum because it's an easier format to generate. So as you can see here, it dumps wave drum trace, which looks like this. I kind of want to show that because this was really useful. I just went on this online editor and then pasted it in. This is how I worked on it, which is fine. It's not ideal, but it does do the trick. And so here you can see this is the cache. This is actually kind of cool because this these here, you can see there's a bunch of cycles before anything happens. And what's happening is the test is trying to assert a read. That's what this primary bus enable signal going high is at address 0, because it's trying to read address 0. And for the first several cycles, the cache says the bus isn't ready. And what it's actually doing is it's clearing its valid memory. So in this case, there's 4 entries in the cache. So it needs 4 cycles to write 0 to each of the valid bits for each entry. And then here we have a cycle where the primary bus is enabled and the bus ready is enabled. And so then that's a successful read. And you can see immediately after the cache, it was a miss. So the cache says the bus is not available in the following cycle. And then you can see here, I stick a dummy address on the read port here. But then it looks like on the following cycle here, no, it's actually on the same cycle here. It's down here. The cache issues a read to address 0 to go and fetch that data after the miss. And as you can see on the following cycle, the test will return some data. And then on that same cycle, we propagate that value back up to the test, which is here. You can see here the data is valid, and it gives you that. And then on the following cycle, it's ready to receive data again. Ready to receive a read, and then you can see we issue a read. Here it's ready to receive a read, and we issue a read. And then in that case, it is a cache hit. And so then on the cycle immediately following, we return the data instead of having to go and read it and return it. So it's pretty cool. I don't think it's weird that you like the logo. I think it's nice. And it's very useful. If you look at the tutorial here, like these diagrams are really nice. And of course the point of this tool is to be able to generate nice diagrams. If you've seen like the Zip CPU blog, for example, I think that's how I learned about this. Did I say Hard Dark Second? Because I meant to. Hard Dark Second. They have a lot of diagrams like this, so it's actually really great. Oh, congrats on starting the new job. That's awesome. And in fact, I think I have a note somewhere to go through the bus. Like I wrote up in the Xenoing repo. I wrote up some docs, doc bus. And here I wrote up like how I wanted these signals to work. And I totally have a note somewhere to make these diagrams for that as well. So you can see how that's expected to work. Which, by the way, I looked at Wishbone recently, and I basically reinvented Wishbone, which is great. That's a good sign in my head. And in future projects, I'll probably start using AXI Lite or just AXI or Wishbone or whatever, like those standard interfaces, just to be able to be more compliant with other things. But I'm really happy I went through the exercise of doing my own thing for this project, and I'll stick with that just because it's cool. At least I think so. But yeah, this is a great tool. It does a really great job. And again, the reason I used it for these temp traces is just because it's so easy to generate. This, again, if we go back to the editor, it still has my data in it. Oh, hold on. Excuse me. This format is just really, really simple. You have like the value here, and then dots mean hold the previous value. You have a P here, which is a positive clock. So you can see it goes like double the rate. And then you also have these where it's like these equal signs, and then those correspond to data over here. Like it's really, really easy to generate. So, and I think I didn't do any coloring here, but you can do that by just changing a number. Whoops. Whatever. Yeah, Zip CPU talks a lot about AXI, and especially using formal verification to like verify that stuff is correct, which is really good. It's good that material exists and it's free, so that's nice. Yeah. Also, yeah, highly recommended. Zip CPU blog is great. I was actually quite proud. I recently read their post about handshakes, and I felt like I understood all of it, and that made me happy. Yeah, I don't understand all of it either, especially not the formal verification stuff. That's something I would like to get better at. And that's another thing that kaze just doesn't support at all, and it probably never will. But again, you could do that via the generated Verilog, but I think that's just out of scope for this project. Anyway, yeah, I'll probably just use VCD though, at least like out of the box. In fact, actually for this test I'm doing now, since my goal is to kind of replace the tracing that I have now with some generated stuff, I'll probably actually just go for wave drum, just to kind of massage what I have in that direction and then worry about an actual one later. That's probably a better idea for the time being. But I think the first trace output that I actually want to like officially support is going to be VCD. I mean, it really doesn't matter. I could support whatever I want. But ultimately there are like WaveDrum, its purpose is to make those diagrams. And so for small ones, it's really good and it's very clear. For larger ones, of course, you don't have all of the nice features that you typically have in a waveform viewer. Because these, if I can find a good picture of some of these, like they basically get really big. As you might imagine. These were not as good pictures as I hoped. But the point is that you typically like preserve the hierarchical structure, so you can kind of go into things and you can do like grouping signals, and you can often do coloring of signals and annotations and things. And generally that's all stuff that you want to, like you want a proper viewer is the point. And at least the open format that everyone uses for this is VCD. So that's ultimately a better default, I think. But again, WaveDrum is easier to generate, so I've done that for my own tests. Anyway, exactly, G Superland. Yeah, I know the feeling. I read that blog a lot. Like every time a new one comes out, I try to read it. And also, I actually follow them on Twitter if you're interested in learning like RTL in general, because I think every Friday they do a like a formal verification quiz or something, and they'll just post questions, and it's really great to read the responses or even just try to answer, because they have really good insightful responses to those, and they're really cool. So highly recommended. G Superland, yes, GTK Wave is an option. The format it uses is VCD. So yes, GTK is like a typical viewer. And supports that format out of the box. I think GTK Wave even has some like format extensions or its own custom format that it supports as well, which again, we want to give users the possibility to use things like that if they so choose. But out of the box, VCD is the natural choice. And then GTK Wave is what I would use. Yeah. Yeah, Verilator's quite okay. I mean, obviously it's like it's basically what kaze does, except it's in C++, and it takes over a bit more of the build and stuff, which I didn't love, but generally it does a really great job, and I think its simulator is pretty fast too. Gotcha, G Superland. That sounds really fun. I would love to do that on like a microcontroller, generate PAL or NTSC signals. Probably PAL, because that's the stuff I have now. In high school, it would have been NTSC. But yeah, like there's nothing wrong with Verilator, and in fact, I started Xenoing with Verilator and System Verilog, but I wanted to integrate everything more in Rust, and I wanted to make a compiler like this and a simulator like this, so I just took the plunge anyway. Not because there was any need to, just because I wanted to. And I'm happy with that choice. It's kind of the scenic route in terms of finishing the project, but it's fun for me, so that's pretty great. And it means I spend time on stuff like this, which is actually kind of annoying, but I don't think it's that bad. and I think it's kind of fun. So anyway, if we go into kaze down here, then we have the compiler, and it's only the sim stuff that matters here. And yeah, so we'll start in sim. Oh, I didn't know there was a library for that for AVR. That's awesome that you point that out, and I will not look at it specifically because that's the kind of thing I would want to figure out myself. I love that exists, and I will not look. I don't want to peek. I'm sure you guys understand that kind of motivation. Oh, by the way, you architecture geeks, I recently found this out. There is more documentation about our core architecture at GraphCore online than I realized. I don't know why I'm zoomed in so much. But I just wanted to share some of this. I'm not logged in or anything, right? Like this is just graphcore.ai. And if you go into, developer documentation, I just have to share this really quick because I discovered this last week. There's a lot of getting started. In particular, this Ipu Programmers guide actually has some really cool stuff. I don't know why my browser's so shit slow right now, but normally this isn't this slow. And in particular, I think this writing vertex code is pretty interesting because this is code that actually runs on the tiles. And there's even this vertex assembly programming guide, which doesn't have instruction listings, I'm sorry to say. A lot of this is proprietary, and it's going to stay that way as far as I know. But there's actually some pretty interesting stuff in here. In particular, I really like... let's see... yeah, these vertex pipeline stuff is pretty cool. Talks about using these built-in repeat instructions and stuff. It's pretty, and how to do dual issue in this pipeline, which is pretty cool. Again, a lot more interesting stuff there and how memory architecture works and stuff like that. I won't show too much of this here, but I just had to share that. I think it's really cool that we have that available. And if you guys are interested in how any of our architecture works, then I'm more than happy to share stuff that we have open because I just think it's really cool. And that's the kind of stuff I work with on a daily basis. That sounds like an awesome project, Graham. That sounds really cool. Yeah, I'm just going to actually write what I think this is, because I don't know. So I'm just going to do that. this should now fail to build read cache, but then we can actually look at some of this. Yeah, so I guess this was the correct syntax. So yeah, if we go into modules now, oops, not that one. I thought it would be that one, but I guess not. Go back to read cache. Dealing with these output files gets kind of annoying, but it's manageable enough, I guess. So yeah, so now we generated that this is here, because obviously that's what happens when you change the string that writes that code. But yeah, we need to be able to use this. So I think I'm just going to hack this like this. Something like that. It's a bit slow because I'm also building this RTL project, which has some helpers that we use in the other thing. So that's why it's a bit annoying, but it's fine. That's awesome stuff, by the way, G Superland. I'm not responding to everything, but I really like what I'm reading. Right, so yeah, so now create trace is not here, right? Because we need to define that. So we'll take this stuff here, which is, where did I put that? I think it's just, I don't know actually. I hope I didn't copy it and then just like get rid of it. That seems like something I might have done. Oh no, it was right there. It's just that I didn't mean to change this one. That's what it was. Great. There we go. Okay, yeah, so here I need to do this. I'm not entirely sure why I need that, but whatever, I guess. Okay, that's building. And then yeah, these read cache ones actually need a type argument, which totally makes sense, by the way. That's great. In particular, this impl read cache one needs that, so let's look at that. Oh, whoops. I did not want to indent there. I wanted to add a new line, which I don't remember how to do that. I think it's just append new line. Yeah, it's this one. That's what I wanted to do there. That's awesome, Daniel Collin. Daniel Collin go burr. Yeah, so this impl needs this as well. And I think the way you do this is you need to do t trace and then t here. I think that's what we need to generate. So I'll just add that here, which again is just going to be this. Not complicated. And then, yeah, these new ones, these are the ones that are actually in the generated module code, and we need to implement that. Is that Seldridge, I think? Thanks for the follow. Appreciate it. Yes, this was, what functions were these again? Just new, actually. Which is this one. I think it's that. No, actually, because we already have the type argument here. And so it's going to be this. Yeah, and then this will just take ownership of that, which I think makes sense. Whoops, and then this needs to return this. Yeah. And then, yeah, this cycle thing here, that's actually in main because of how I did the testing here. But the generated code just looks like, yeah, as you'd expect, it will read cache T, and then we take new, and that takes in one of the T's, which is great. Nice and easy. Yeah, it seems really pointless to have a password on those kind of archives. Not pointless to use like a standard file format for that. That's probably smart, but yeah, I don't see the reason to password protect that at all. This is totally a tangent, but I always liked how if you do something like TANS, you can actually, for a table with like roughly the same statistics, or like the same statistics can generate a state table, and you can have different permutations of the state table that give you almost exactly the same compression ratio. But those different permutations can actually be used as a form of really kind of basic encryption, which I think is actually really cool. So the encoder and decoder have to agree on how to initialize the table given the statistics. But yeah, it can be used as some kind of... I don't think it's like cryptographically secure by any means, but I think that's kind of a cool thing anyway. But yeah, even then, I think in that kind of use case, it's pretty pointless. I just always liked that was a degree of freedom that those coders had. Although for a naive implementation, I think that actually can affect compression. I think Charles Bloom has some blog posts about that, about how in those tables, some of the lower positions are actually more statistically likely to occur in real state values than the upper ones. And I didn't fully understand why that was the case, but you can actually use that to your advantage when you're figuring out the states. Kind of cool stuff. Yeah, that's especially dumb, Daniel, that they had the exe uncompressed, so this password was just in it. That's funny. Security through not even obscurity. I mean, what if I do this? That's what I want, right? Yeah, so now that made all the types line up. But now, yeah, trace is not implemented for test trace. So this was correct syntactically, but I haven't implemented this. And also, these parameters are unused, which is an error in the generated code. So great. So we made progress. Do I even need this num cycles thing? Why do I have that? Oh yeah, I figured out here when I'm dumping stuff. By the way, this actually, I'm actually not sure if this is a great approach when I think about this, because you're not supposed to be able to do things that can panic during drop. And I'm kind of relying on this to close files and stuff. It's probably fine. It's probably fine. I'm going to ignore it. Why do things right when you can do them fast? I don't know why it doesn't like this. Probably because of these. That's probably it. That is a lot of red. Okay. Yeah, so then here we actually split this up now. And here we're going to do a couple things. First of all, up top, we want to use this. Use trace star here. We're going to implement trace. Let's copy this. So this is not going to be correct now. Yeah, and I think, by the way, this definitely makes sense. I didn't put these here at all, which is stupid. Yeah, I'm sure that affects basically everything, Daniel Collin. It's so bittersweet doing that. That's one of the things I need to write about with kaze, actually, is that it uses panics for all the error handling. And there's actually the reason why I did that is because when you're describing a module, like in this build script, you want, like, for example, output here. Not actually, that's a bad example. This drive input with this read port. When you do this, when you call drive input, it's going to check that this signal has those same number of bits as this input and that this input exists. And if it doesn't, you want to have an error here. And you actually, in this case, I chose to panic because then as a user, if this panics, which you can see here, then I actually know via the stack trace which line of my RTL code that panic came from. So I think that kind of makes sense from a user perspective, but ultimately it might be better if instead I have all these as like macros, and that can insert like the file and line information, then I can report a proper error with more than information, but that's a lot of work. So for now, I just panic everywhere, which I think is a good kind of middle ground, but eventually I might do something more proper. No, I didn't see that leak. I saw that a leak had happened, but like that and also the Nintendo leaks that have been happening are so bittersweet because I want to look at that stuff, but I also don't, right? Because who knows if I like unknowingly infringe on a patent later. I don't want to have looked at that stuff, but it's so tempting. And I think it's, yeah. There's also the moral side of it that I'm not sure how I feel about right now, to be honest. Like I find it exciting, but also kind of sad in a way. And I'm just not sure. I just don't know how I want to handle that yet. So I've just been avoiding it. From a purely technical perspective, I think it's really cool and I'm very curious. Let's put it that way. But for reasons I'm trying to avoid them. But if I happen to see someone's tweets on my Twitter, I'm not gonna not read them. Though I haven't seen the ones you were talking about, so that's funny. This error crate. Okay, I'll check that out. I always forget that there's helpers for that stuff. But of course there is. Also, thanks, GC Berlin. I will definitely check out that link. Yeah, whatever I do for errors, it's paramount that I get like file and line information at least. That's definitely something I need, and maybe something like that just works, which would be cool. I have no idea actually, but I need that as like, because of the fact that this is like an embedded language, I need to know where errors came from in the user code specifically. That's kind of the annoying part. I'm just peeking at this error documentation. That actually looks really cool, especially that it ends up being transparent from a user. That's really cool. It's just convenient stuff for printing all this. I like that a lot. Some other helpful things. Cool. But yeah, there's other reasons why I want to panic as well, because if you do things like ops add, like I implement those for signals, and then how do you propagate errors from that? I guess you can make the input arguments both be results, and then everywhere I have signal in my API, I instead have results signal or a compile error or whatever. Or maybe like error context, because then you could kind of collect multiple errors if you have any kind of recovery in the compiler. I don't know. It's a mess. So for now, I do panics and I rely on the stack trace, which is not ideal, but I think it's okay for the use case. Because typically those kind of errors, they're going to occur if you make an invalid graph. So at the very least, you need to, you need to be able to handle that kind of stuff. Or I guess that's not the sentence that I wanted to say. But they're like fatal errors is my point. This is not something that you would typically write code to recover from. Like if you have bad RTL, you will generate bad code or not be able to generate code. So you should just stop anyway. There is actually a couple parts in the API where I return a result, but it's an IO result. So that communicates that this can cause IO errors, and you might want to like collate those. Is collate the right word there? Collect those with other IO errors, but yeah. I don't know. I'm talking a lot about it because I'm still a bit like, I'm not sure I love that, but yeah, it's the right choice for a first implementation at least. That I definitely am confident in. Let's see. So I want to do some trace stuff here. So I'll do, oops. Do I need to format actually? Because it's just going to be this. T even. Oops, and then I wanted to do this. So at the end of all this, like that. Yeah, I definitely agree with that, Daniel Cullen. As a media player, you have to handle basically all errors gracefully. And errors are very likely because you're going to have input from users. So I think that's another case that's like different here. If I were to categorize it, is that this is input from the developers that they need to know what was bad and where, which is probably not conditional on like user input. I mean, that's not always entirely true. Like, it's possible that like you might be making a library that uses kaze to generate a particular kind of module, and then a user of that API like would like to know. I'm not actually sure, but yeah. Either way. What was wrong with this? I don't understand. Oh, these are errors in main. They're all errors in main, actually. Okay, great. Yeah, right. Of course, it's these that are causing errors, which we will get to. And then, yeah, we need... Right, and now... all this .cycle stuff is going to go away. Because we're not doing that anymore. For most of these, I want to do this, except this one I want to do this. Because now this pause edge clock is going to end up doing everything. So I think this might build. It didn't, because now this needs a parameter, which will be this. And what's wrong here? Oh yeah, I need to have actual definitions for these functions here. To do. And then yes, I need signal ID. Look at this error. That's great. Provide a definition like this. Can I just say, I feel like I haven't said this in a long time, but Rust errors are the tits. And that just made me really happy. I might even make this usize, because I think what I'm going to do is have just like a vector, and then I'm going to have it indexed by this. So I can make this whatever I want. It's my own testing, so that's great. And then look at this. This even tells me that this thing is wrong, but that's actually okay, because I'm going to instead do this. This is actually what I want to do here. I'll do that here too, actually. Okay, I don't know what made those dots. That didn't make any sense to me, but okay. Why was this suddenly really high? That was strange. I'm really confused why I did that. Was there anything useful before this, or was it just... Okay. No idea what's happening here. Num cycle shouldn't wrap. It shouldn't run that long. I mean, maybe, yeah, I should try debug. I'm not going to say I didn't mess anything up. I'm quite sure it's my fault, but I have no idea why this is happening. You know, I might also do a git diff because I think if, like, I did a change where I removed all that extra debug printing, and if I accidentally remove something I shouldn't have, then maybe this loop never finishes, in which case I still don't know why it would dump a bunch of periods, but oh, here we got subtract with overflow. Main 120. This is probably relevant. That's here even. Oh, yeah. There it is. So it was overflow. Oh, there. That's what you mean. Yeah. Yeah, nice catch. That's totally what it is. That's funny. I don't really know what to do when num cycles is 0 in this case. Let's do this. Nope. This is just a test dump anyway, so now we should see nope. Yeah, good catch. Nope. Great. But that's good. That means the simulation is, well, might still be working. I think it does what we want. Expected 2 arguments, found 1? Really? That's gotta be wrong. I don't think whatever that was correct. Also, I'm not sure. Let me look at something here. Yeah, so I never did trace after reset, just on these clock ticks. I might also want to do it on reset. I'm not actually sure about that. I use these debug messages when I'm doing like temp stuff and like hacking things, but I always clean them up after. I'm sorry to say. By the time they're on master, they don't look like they do when they start out. But I totally do this stuff like while I'm actually hacking things. Definitely. Yeah, that'd be awesome, G Superlin. But nope. Not by the time it gets to master. I don't think I could live with myself if I did that. Okay, so I want to actually emit some calls to trace. So for example, in posage clock here. Oops, not here. Here. I don't know if I've seen the latest stuff. Probably not if it's super recent, but I have seen some of that stuff that's really sick. Whoa. Yeah, not yet implemented. I'm kind of surprised it gave me a stack trace because I didn't ask for that, but I don't really care because it did do the right thing. Or it kind of didn't actually because it not yet implemented and then got to nope still. Oh, I know why. Because it did not yet implemented, and then that started unwinding the stack, and then nope happened in the destructor, and that's why we got this backtrace. Thread panicked while panicking aborting. That's what happened. That's why that happened. Fine by me, by the way. I definitely don't care. At the moment. But I will do this, actually. That's probably a reasonable thing to do. Great, so now actually we even see these. Cool. These periods are the ones we wanted. I'm definitely saving that link for later. Daniel Collin, that's going to be awesome. I think GANs are so cool in theory. Like, I love that approach. Where you train one network to generate crap. Or not crap, but like... well, yeah, actually, you train it to generate things that look real but aren't, and then you train the other one to detect whether something's real or not, and that feedback loop makes the generator better and better. It's a really cool approach. I don't know... I've heard that those are... I've never tried myself, but I've heard that those are actually really finicky to get to train properly. Haven't tried it. I tried some autoencoder stuff in like Keras a while ago. Like this is... honestly, my ML knowledge is pretty basic. I know what it looks like from like a workload perspective, and I know a lot of things we do to make it faster and stuff, but I don't actually know that much about a lot of the approaches. I would love to learn more. I think it's really cool. Yeah, that's true. Definitely. Yeah, absolutely, G Superland. I agree. All right, let's generate some of these signals. I actually don't know entirely what I want to do for that. To generate these signals. Yeah, this is where things actually might start to get complicated already. So you can see now, yeah, positive clock calls the trace. Because there's a lot of these. Well, I mean, we don't need the temps. We only need these ones that are going to be actual signals. And we also don't really care about these next signals either, because that's just to feed into the registers for the next values. We only care about what the current values are, I think. Maybe. And maybe this isn't even the right place to do this. Because maybe I actually want to do it after I update everything. In which case I probably also want to do it on reset. I'm not sure. I'm going to hack it for now and then think about that later. In case I need to... yeah. Generate some function to update all the trace stuff and then call that, which I could easily do. In fact, I can even do this. Yeah, so the trace hack that I had, I think I had it before, and it was just it would take the current values before they transition, which the dead values, right? Because before they transition. I don't know if that's the right approach, but it's the one I'm going to do first, so that's great. Yes, the temp values that you see here, they're only intermediates. Exactly. And I get really aggressive with generating temps for expressions, because if not, then when you start generating code for these, then you have you might, every time you use this expression, it might get expanded, and you can have cases where you might repeat a signal n number of times, and it'll repeat this expression a bunch of times. Where like the easier way to do it is repeat this a bunch of times. So I really aggressively make temporaries and then let the Rust compiler deal with that, or the Verilog compiler deal with that in this compiler. So it grows like linearly vertically rather than potentially super linearly horizontally, if that makes sense. It being the generated code. Yes, this is just the output of the kaze compiler graph. I did not write any of this. And it gets pretty crazy sometimes. But the input to this wasn't this bad. Anyway, yeah, so what I want is, it's going to call this trace, but before that, it's going to need to update all of these signals. And before that even, I need to decide which signals I want to trace. Definitely not Morning Sci-Fi. Definitely not. Nope, that's the compiler. Yeah, so that's actually another thing that we have to do, is right now I add a field for the trace, and I need to add other fields for these signal IDs, don't I? I think I do. Gretchen, why not go directly to LLVM bytecode? Because then I need to build LLVM. This is whereas if I generate Rust code, then I just build it with the Rust compiler, which I already have because I'm using Rust to run this API. So yeah, that is also the case. Like, this is for generating a simulator for hardware. So actually the main case is to generate Verilog, and then the secondary case is to generate an equivalent simulator in Rust. Rust does use LLVM, but there's that doesn't mean that I've built the Rust compiler and have access to feeding the Rust compiler LLVM bytecode. So I generate Rust and put it through the compiler as well. That's what that is. Yeah, so I think when I'm like collecting signals here, actually, where do I do that? I need to look at this again. So for example, yeah, we gather up all the state elements and everything. We go through all the memories and registers and everything. This name here. Right, name comes from the outputs here. Yeah, the outputs in the registers, we actually know we can use those names and that they're unique because the compiler ensures that that's the case. That's what this is. Right. I think it's going to work to basically add like this. So if we add something like that, is going to be, you know, T signal ID. And then like down here, we would do, I think it would just work if we did T dot whatever that other function was. For example, I think this is what we want to do. Oops. Which means we need to generate names for this stuff. So how does that happen in this compiler? I don't remember how I did that. I would do this gen temp thing. No, that's something else, isn't it? Maybe it's the assignment context that does this. No, that's local counts there. Compiler, maybe? Need a refresher here. You know, I could just make a context and make these all temps. That would actually be okay, because I don't need to know the names of these. And they don't need to be like pretty or anything, because they're all internal. So I could, let's see. Like in other parts of this compiler, I make, like here's this root context. I don't actually know what that's supposed to be. I don't remember. I think it's just like a stack of contexts, which I don't remember why I did that. I think these contexts are just the structure that holds all of like the intermediate compilation results, if I remember correctly. And there's, so I think that's more just a detail and compilation. And then it's these assignment contexts. I think that's what I want to do. And I could make, yeah, I'm not sure if I like it conceptually. But I could make an assignment context for like the struct itself. And it should be fine, I guess. Yeah, I'm going to start writing it that way and see if that's okay. I don't think I love it, but probably fine. So do something like let mute trace context. does this suck? Two question marks. And then, so what I do here is I have these different contexts for the different functions. So this is there's a prop function, and you want to go through like all the registers and stuff and add assignments that are going to go into this function as you go through different parts of the different structures in the compiler. And then, so if I have this like trace context, then those are going to be temps within that context. Then I'm going to emit code for those in the constructor, actually, I think. So actually, this may not even be the right approach for the code I'm going to generate. The only thing it would really give me is this way of counting locals. And the assignments to them don't really look the same either because I'm not doing like general stuff here. So I don't think I like using this mechanism for this. Yeah, I definitely don't like doing that. I'm going to have to do something custom here, which is fine. Actually, what did I call some of this stuff? That's like num locals, local count. Then I'll call this something count. Yeah, really I want to do something like this, and you have the name, which is a string. That's it, actually. So then here we go through the outputs. Well, I'll start with like the registers. Doesn't really matter. Here's the registers, for example, and then I can do I don't even know if this needs to be a vec or anything. This could just have been a set, I guess. But whatever. Something like this, and then let's see. Yeah, I guess actually we want to do something like this. By the way, I really like doing this kind of thing where you just make like a local type and just kind of do whatever you need with it. And then, let's see. What do I want this to be? Member name. You just do whatever you need to, and then you either leave it or you lift it out. But this stuff is really nice to just like throw something together like this and then clean it up after. I think in actual code, I think I've only done this a few times. These local functions I do a little more often, but not as often either. Or I mean, not that often. But I like this approach. So then we do true. Actually, we'll do let member name is format like this. So we'll just do name. I know this won't build, but I hoped the compiler would. All right, 331. I did this a couple times. It looks like. Oh no. We can do this. Oh yeah, and that needs to be like this, and I think maybe that's fine. I think. Yay. Yay, lambdas. That's great. Right, and now we should see that, yep, we have these signal IDs. It looks like I added even more underscores to these reg names. That's kind of funny. So I probably don't need to do that. I'm just going to fix that because why not? In fact, actually, I think what I've been doing is like prefixing these. So what I should rather do is something like this. Not terribly important, but. So I think these lines are correct. We can see if that generated any errors. I don't think so. I think it's all just the add signal calls that are the issues. It's a lot more than I thought, but I think that's because of the stuff below, which I can explain why. Yeah, it looks like this stuff is good. So then here, yeah, because it calls trace.addSignal, and it says addSignal expects 2 parameters, which is even better. And those 2 parameters were the name and the trace value type. Now the type we need to figure out, so we'll worry about that in a second. But then the other reason why this caused a bunch of errors is because I have this other module which has a lot of registers. So you can see here it generates a lot of them, which is great because every line this generates is one that I didn't. So that's awesome. So yeah, so this will generate strings. So let's do that really quick. And this is why we needed the original name, because here we need to do this dot into. And then I'm going to do a to do here, but I'll do baby steps. Used more than once. Yep, I had these in the wrong order. That's funny. And this into needs to be a function call, because essentially what I'm doing is this, I made this API take a string, but I'm only generating string literals here. So I'm calling into on that. And maybe it makes sense to just use static strings for that input actually. To be honest, I'm not sure what the best thing is there. Although actually that probably is best, since that's what I'm gonna have. So I'm actually gonna just make that change. And then this one here. Oh yeah, and I can just fix this other error here too while I'm at it. So that's here. Because trace going in here is going to be mutable. Yeah, I don't see a reason for those Alex. I like the idea that it would own that data, but it can clone it if it needs to. The literals are going to be there anyway, so yeah, this should definitely just be better. What? Okay. Just gonna swap the order here. so that when we, yeah, as we're calling all of this, we should just be borrowing this trace struct and then we assign it later. Oh, my headphones are so loud. I don't know how to pronounce that name, but thanks for the follow. Yeah, this is great. Not implemented, although it says here for identifier to snake case. Well, I guess it didn't like these. That's kind of annoying. I might add ignores for those. I'm just going to do that. Allow non-snake case. And I can just do it for all of those fields. Yeah, I could. So the reason I can't add extra temp is because this name, well, I mean, I can do it somehow, but this name is literally this. What's this? Yeah, this string is this one, which already has underscores there. So I would need to get at it before this, which I should be able to do, right? Maybe that's easier, actually. Not that it's terribly important, but where do I add that again? Here. Yeah, it's when I collect these. But I think this register here, yeah, it has this data, and I think registered data just has the name. So I could just grab that. I don't really see a reason not to, actually. So that's actually kind of better. And then it's possible that a user can generate a name that doesn't end up being snake case, but I don't really care to fix that or try to work around that in any way. Yeah. There we go. But again, these types are crap. I think in this compiler IR, I have some kind of type already, because these expressions need to be typed. Yeah, this value type here. So I could reuse that. That's probably just easiest. I think I'm okay with that, because that is what this represents. So then that'll be, does this expression have a type? I don't know if it does, actually. I don't think expressions necessarily have types, the way that I've written this. But I would expect this register would, actually. Or maybe not. Yeah, I actually don't think we have the types here. I think the compiler ends up getting those from the original signal, which I guess we can do. Yeah, because we know the signal's bit width. Let's do that. And that can be this. Let's see. In fact, we can even call this signal here, the signal that we're compiling. I think that will work. And then this needs to be, let's see. Like that. Oh yeah, of course they'll even figure this out. Great. Actually, I think we can even do .type.name. That might even work. I don't actually know if it will, but we'll just hack it until it does. I should open multiple views on this file so I don't scroll so much. Or I'll just complain about it and then not do anything. Yeah, so name actually will not work. That's not what we want. So I need to match on it. I might actually make a different structure for this. Where I'll just duplicate this. Now we have bool, and then we can do something like that. Oh yeah, we will definitely want to use this kind of thing. Also, these might be the only cases that we have, which is kind of nice. So it seems like I'm duplicating code here, but these are conceptually different types, so I'm actually quite okay to do so. And this kind of constrains it because this is only going to have, you know, these 4 types or whatever. Whereas the other one's actually a little more general. But this is definitely what we want here. Because this internal part of the compiler actually has no knowledge of assignedness of values, which I'm going to keep it that way. Which actually, later we might want to have the trace actually try to dump signed values for some of these, but I'm not sure how I want to handle that yet. Yeah, because now this says value type from bit width. Oops, that's in here. needs to be a bit width, and then later I think I can do this even. Actually, no, I don't want to rely on format for that. I mean, I could, I guess. No, I'll just do this. And I need to stop streaming soon, but not quite yet. And this is actually, I already realized something that's kind of interesting here. So two things here. We need num cycles, and then we also want something like this, like signals vec. Signal, something like this. So add signal is going to do this. And we need the previous value here in order to know if it changed. I guess we can make that an option for now. Yeah, actually, I kind of like that. So yeah, we can even do value. Or actually, we'll just do value. I think, what did these do? Because I had these other signals here. Value is a vector of bools. Oh yeah, I added just values. Yeah, that's what I did. I'll do that. This is kind of crap, but it'll work for now. Because this doesn't really stream the data, which is not perfect, but it's going to be fine for this. Yeah, work for now. It's definitely good. Yeah. So then we need name. And we can do the type here. We'll do that actually. We'll add a type to this. Then we can check that later. Like that. And I also want to go, that ran by the way, which is cool. So I also want to go one step farther and do something like this. For signal in self.signals, then signal.dump. And we can do this. We can do impl test race signal, dump self, and then we're more or less going to have this logic. And this was different for booleans. entirely sure. Well, I could just do this. Actually. Can I do this? If let without destructuring anything. That's kind of nice because then I don't necessarily need to derive EQ and stuff, which I don't know if I want to do yet. So that's kind of cool. I think the Rust library guidelines or whatever recommend you to always implement these when you can. So that's actually probably something that we want to do. And then we would just use equality here, which would read a little bit better. And then otherwise we would do this longer path. I'm just going to duplicate it for now because that's fine. Something like that. Of course, this will not work. This will be self.name, self.name, and then values is the same, except these values were originally just numeric, but yeah. No worries, Daniel Colin. Thanks for hanging out and the tips and stuff. Yeah, this definitely won't compile, but we'll deal with that in a minute. In fact, one of the things we can actually do, pull trace value. We can even do this explicitly, which I kind of like. Like that. And then here we can do, actually I think numeric value. Did I call this, I wanted to call this 2 numeric value actually. And then well, it's fine. Basically going to do the opposite here. So these will be, whoops, like this, and we can do this, and that, and that, and we can then put these together. And then we do value and value. think that might just work. Or not. Yeah, why is this trace value now? That's why we want to do let here. And I think that's wrong, and I think we just want to do that even. 39. Where's that? What? Oh yeah, let's do that. I think works. Same with that. Now 225 it didn't like. What's this? Oh yeah, I could do the same thing here. $27. Oops. $251. Or was that? Yeah, that's fine. We can do .iter here. Look at that. We even have all the values, or well, we have the signals. We don't have any of the values. I think I'm going to push through this really quick and then call it quits. Now, of course, this isn't every value because we didn't do any of the outputs, for example, which I think the old trace also did. It probably did inputs as well. So maybe I'll hack those quick too. But first I'll actually do the values, which is going to be, well, we need to do the calls for that as well. So I think that'll be relatively easy. We just add them before we call positive clock in here. Let's see. Gonna basically copy this. What do we want here? I want to call add value. And so for this, yeah, I want the member name here. And then we want just the value, I think. The value is going to be a trace value, so we're going to do this. It's going to be something like this, and then that's the type, and then we have parens, and then the value. And the value is going to be I think it needs to be self dot here. Might even work. Okay, so interestingly now it broke in the generated code, which is good. Yeah, so here we add all the signals. Actually, let's go up a bit. Yeah, these need to be self, first of all, and then I think we mismatched some parens. Maybe not. Oh yeah, these are commas. Yeah, it's not bad actually. It's could be a lot worse, couldn't it? Mostly that just really helps me when debugging the compiler. So that's a good thing to do. Oof. Oh yeah, this needs to be the actual yeah, this can't be this name. We need yet another name. Value name. And so then that's going to be this name here. Actually, it's going to be value name. And then when we later go and do this, we need to do, oops, next one, value name here. Yeah, these signal IDs, they don't implement copy. I guess probably the best way to do this is change this add value interface to take a reference for the signal ID, because then this could be anything. So I kind of like that rather than, for example, adding constraints to this type. I think I want to just take a reference here. And then it's easy to generate code for that because then we just do this. And then I think it'll crash at runtime, but I think it'll run. Yep. Because this is not yet implemented. And so then we have to do that. So this should be relatively easy because I think it's just to, yeah, values.push. So self dot signals, and then this will be signal ID dot values dot push value. In fact, we can do this. Like this. In fact, since that's a reference, we can just do this. If let's just do this actually. And then not care about it, because I'm gonna assume it's correct. Look at that. This may have even worked. Where's this one? I'm going to open this twice because I want to keep that other signal in there. Okay. That's funny, actually. False, true, false, false, true. Yeah, we definitely generated that wrong. So for binary signals, when we're generating this trace, we actually don't want... That's why I cast that as U32, isn't it? That's for Booleans. That's cute. That's why I did that. There we go. All right, great. So for... Oh, whoops. Did I close that other tab? Did not mean to do that. Oh, well. For the signals that it shows here, I think these are correct, which is great. Couple things. I'm going to go ahead and actually remove these debug ports that I added. Because now I know I don't need them. Is this the right one? I thought it was. I thought I added these. Debug? Oh, I did these match things. There. Debug state, debug issue buffer occupied. These are no longer necessary because we add a lot of stuff to this trace. And as you can see, these state and issue buffer occupied are already there because the compiler has access to these internal things, which is great. This is actually cool too, because this state wasn't in there before. This is the invalidate address, and you can see that that counter actually just keeps going even when it's not invalidating, just because it's easier to not stop it. So that's pretty cool. And now I want to hack inputs and outputs for this too. And then we'll be good, I think. Which should be a matter of calling this again. So this is on registers, and then on these inputs and outputs, which we'll get to, but I just want to do, well, we'll start with outputs even. Inputs might actually be a little tricky because we don't know if stuff is propagated here. So this actually gets kind of messy, but whatever. Graphs of Wrath, yeah, definitely. You know, also I might want to add like a specific trace function so that you would call this at specific times and it would pull all the values then. I don't know. We'll see. Yes, definitely GraphCore. Right, because the signal actually is this already. And then what about the name? Name is here. Actually, I think this is the one we want for a name. Isn't M the module? Yeah, I guess in this case, they're both the same thing. That's probably what it is. Oh, totally, Gretchen. Yeah, it's awesome. And they make, it's much prettier when you add like the colors and stuff versus what I'm doing here. But yeah, great little tool. Look at that. So another kind of downside of this is that we don't guarantee like any kind of order, but I mean, most of the data is here. Not all of it, because inputs are not listed here. But I don't know, this is pretty cool. Yeah, no VCD today, but I think that ultimately is what I want to move to. I just did Wave Drum because I already had that hacked in here, and then it's easier to take my hack and turn it into a different hack than it is to start a new hack. In fact, I can actually just remove a lot of this other stuff now already. That's pretty cool. So yeah, so getting this to like work initially is the easy part. The rest is going to be cleaning this up, making it conditional, and making all that nice. All that kind of stuff. But yeah, the next step would be to move this to VCD, I guess. So that's the primary output I want to have eventually. Yeah, that makes sense. Yeah, I don't know if that's true. Don't think it is. Anyway, yeah, I do actually want to hack the inputs really quick. And these buffer states as well I want to do, but I think that makes sense. That's pretty cool. So now we should see, for example, that the let's see. Yeah, we also want to qualify these, I think, maybe. Maybe not actually. Yeah, because it's the bogus address. So yeah, so on this cycle, we can see, yeah, primary bus is ready. And this should have been primary bus enable. So it's been trying to issue a read to primary bus adder 0. And then this is successful in this cycle. And then, yeah, goes down and forwards that read to the replica. The replica responds. Then we respond to the test. I mean, this looks perfect. And that's another thing, actually, as I'm seeing this, is conditionally you may want to like enable or disable different signals. I think you actually don't want to, and like if you're doing WaveDrum, you might want to, but if you're doing VCD, I think you just kind of want everything that you can get your hands on in there. Yeah, in this case, it would make sense to group them, but I think I'm going to skip that because, I guess a proper WaveDrum thing might be able to do that, and you can kind of, like the diagram thing has support for that kind of stuff, which is actually nice. It has support for grouping like that. And also VCD, we want to group based on like the hierarchy, whereas the hierarchy gets like flattened in the compiler. So yeah, actually we'll want to support grouping for that purpose for sure. And in this output, I would definitely want to group it, but since it's just a hack, I'm not gonna. Here, I think we want to add trace signals for both of these. I'm not sure I love this, but I don't know if this is going to be correct. But I'm going to just try it anyway. Right, because this is going to be not address.bitwidth. This is going to be mem.adder.bitwidth. Is it not? That's mem.mem.address.bitwidth. So some unpacking there. Because this mem struct is the one that this, oops, did I do control B again? I always do that. Is it B? I think it is. Yeah. This mem that we have here is the temporary that's created by this code generator. And then it contains a reference to the mem in the graph. Yeah, now we have these crap names here. But again, that's fine for now. We should see, now we even see these memory read ports. So you can see when it issues a read, it actually issues to these, to the data read, the data memory, the valid memory, and the read port memory. Which is kind of cool. It didn't contain the value, which is something that we would want it to do as well. I think. Actually, no, we wouldn't do that because read ports are inputs to the memory, and then these write ports are as well. It's literally going to be this. Element bit width, that's what it is. Okay, this ended up being a long stream. Whoops. Oh well, I think I'm almost done for today. In fact, if this works, I'm done for today. So still pretty messy, but it's definitely a good like proof of concept to do this in the compiler. Gonna need a lot of cleanup. But I'm pleased with this. This is as far as I could have hoped to get today, I think. Yeah, lots of signals here. Because you can see like these read port addresses and the write port addresses here. There's a lot of extra data. So I'm going to add another to-do, and I'm not actually going to push this yet. It's just going to live on my hard drive for a bit. Yeah, in fact, that actually should be here in this. Yeah. Yeah, because actually, for example, VCD, I'm just remembering this now, actually allows you to specify parts of the module hierarchy and where different signals live within that hierarchy, in addition to just adding signals. Whereas this is just flat, and that's actually not what we want. We want to have the compiler output that information somehow to the trace thing. And the trace, if the trace ignores it, then it can just do something flat like this. But ultimately, we want all of these to be in a hierarchy as well, especially when we get to VCD. Like, I need to know that this memory is the memory that was on within this module if this was in like a larger trace. But again, for today, this is perfect. We got this to work. No worries, you Superlin. Great timing, because I'm going to go as well. So yeah, thanks guys for hanging out, and I'll see you next time.